Alright, starting lesson 7.5, Systems of Inequalities. Alright, to graph a inequality, or a linear inequality, it's the same as graphing any equation that you graphed before with one additional step. So here we have y is greater than 2x plus 1. Just imagine that was the equal sign to start with. Well, you have the slope, which is 2 over 1, and the y-intercept, which is 1. Alright, so here's the y-intercept. And then applying the slope, we go up 2, right 1, up 2, right 1, up 2, right 1, go down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1. All right, and then we have our line using those points. Now there's two questions you have to ask yourself. Is the line solid or dashed? There's no equal sign with this inequality, so we have a dashed line. All right, and it says y is greater than. Greater than means we shade above the graph. Okay, or on top of the points. Let's do another example. Graph y is less than or equal to x squared plus 1. All right, there's various ways to graph this equation, but I'm just going to choose a bunch of points. All right, and you could use this method for graphing any equation. Okay, this is the most simple, basic method. All right, so I just plug in the x values and I figure out what the y values are. 5, 2, 1, 2, and 5. All right, plot my points. Negative 2 up 5, negative 1 up 2, 0, 1, 1, 2, and 2, 5. All right, now is my parabola dashed or solid? Because there's an equal sign here, it's solid. All right, so solid line used for the curve. All right, then it says y is less than. So that means we shade below the points. All right, below the points. And the parabola keeps going to the left, and it keeps going to the right. So I'm shading under it, even though you can't see that right now. All right. And the shaded regions represent the solutions to the inequality. Let's do some more examples now. All right, sketch the graph and label the vertices of the solution of the system of inequalities. All right, simple stuff. As simple as these two equations are, students mess them up all the time. It's as simple as this. Find the line where all the x values are 3. All right, x is 3 here, x is 3 here, and here, and here, and here, 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 and here, and here, and here. Okay, that's all you have to do. And then ask yourself, is the line solid or dashed? Well, there's an equal sign here, so it's a solid line. And am I shading above or below? Well, since it's a vertical line, there is no above or below. It says greater than. So you're either shading to the left or to the right. Greater than means you're shading to the right of the points. Okay, now let's work with the y. All right, where are all the y values negative 1? Starts here, and 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 there, and there, and there, and there. Okay, is the line solid or dashed? There's no equal sign, so it's a dashed line. Okay, and it says less than, so you're shading below. All right, now your solution is wherever the shaded regions overlap. All right, that green region represents your solution to the system of inequalities. Now let's do another example. All right, before we graph the inequalities, we have to get y by itself. Okay, so for the first equation, I start at 1, and I apply the slope, -1/1. Let's identify all the pieces of information we need for all of the equations or inequalities. Alright. Alright, so for the first inequality, start at 1, then you go down 1, right 1. Alright, that's the first one. Up 1, left 1. Alright, and is it a solid or dashed line? Well, there's an equal sign, so it's solid. Okay, for the next inequality, we start at 1 once again, and we go up 1, right 1. Is it solid or dashed? There's an equal sign, so it's solid. And then for the last one, all right, y is equal to 2. All right, so we have y equals 2 for all these here. All right, and it is also solid. All right, for the first inequality, it says greater than, so I shade above. For the second inequality, it says greater than, so I shade above. And for the third, it says less than, so I shade below. Alright, now you have to pay very close attention to where the area of intersection is. It's actually this small triangle right here. Okay, so that represents your solution to the system, but they want you to find the vertices in this problem. Alright, so a bit more work is required. Alright, to find the vertices, you just have to set every two equations equal to each other. So I'm going to set these equal to each other now. Negative x plus 1 equals x plus 1. Subtract x. Negative 2x plus 1 equals 1. Subtract 1. I get negative 2x equals 0. Divide by negative 2. I get x equals 0. I plug it back in just to the equation itself. The first one or the second, doesn't matter which. I get y equals 1. Okay, so that represents one of the vertices. So that's going to be this one right here. Make a blue line. So one of the vertices is 0, 1. And let's set these two equal to each other. So I have 2 is equal to x plus 1. I subtract 1. I get x is equal to 1. And I plug that back in to here. And I get y is equal to 2 plus 1. Sorry, that's not a 2. That's a 1. So I get y is equal to 2. All right, so that's another one of my points. That's this point right here. All right, this one here, which is 1, 2. And then there's the third point. Let's see. One more arrow here for this point. Okay, so that's going to be the first and the third equation. So let's give myself some room on the bottom here. So I have 2 is equal to negative x plus 1. So I subtract 1, get 1 is equal to negative x, divide by negative 1, and x is equal to negative 1. All right, plug it back in the first equation, and I get negative of negative 1 plus 1. So I get y equals 1 plus 1, y equals 2. So I end up with negative 1, 2. All right, that's what I'm going to have here. Okay, so we figured out all the vertices. We found the solution for the system, which is the yellow shaded region. All right, we're done with this example. On to one more. Sketch the solution set of the system of inequalities. Okay, this is the equation of a what? It's the equation of a circle. All right, so recall, the equation of a circle is it's x minus h squared plus y minus k squared equals r squared. Okay, the center is your hk, and the radius is r. Okay, so in this problem, pretty easy. The center is going to be 0, 0, and the radius is going to be 3. Okay, because you could rewrite 9 as 3 squared. Alright, so we have 0, 0 for the circle as the center. We go up 3, down 3, left 3, and right 3. We have left center equal to, so it's going to be a solid line making the circle. And it says less than, so you're either shading inside the circle or you're shading outside the circle. Less than means you're shading inside the circle. Alright, for the other equation, alright, we have m is equal to 1 over 1 and b is equal to 2. Alright, let's graph our line. So here I have 2, and then my slope is up 1, right 1, down 1, back 1. Okay, and it says greater than, so it's going to be a dashed line. Okay, and I'm going to shade above. Now where do the shaded regions overlap? Right here. And that represents your solution to the system. Meaning I could pick any point from this green region, plug it into either inequality, and it's going to work. All right, if you have any questions, please make sure to ask. Begin the assignment.